Hey, welcome to the Explainer. Today, we're tackling a classic coding problem that sounds super simple, right? Just add two numbers. But there's a twist, a really interesting one. What if the numbers were given to you completely backwards?
So yeah, think about it like a puzzle. Imagine you've got two numbers, but you can only look at their digits one at a time, starting from the end. How in the world would you add them up? Well, that is the exact challenge we're going to break down right now. Okay, so here's what that actually looks like. The numbers come in as this chain of digits. Programmers call this a linked list. So if you see a list like 243, your first instinct might be 243, but nope, remember it's backwards. So that's actually the number 342. Same deal for 564. That's really 465. It's kind of weird, right? It definitely makes you stop and scratch your head for a second. All right, so let's put a pin in it. Here's the official problem. We get two of these backward linked lists, where each little link in the chain is holding one digit. Our mission is to add the two numbers together and return the final sum. So using our example, we're adding 342 plus 465. Easy enough, that's 807. But, and this is the final twist, the answer has to be in the same backward format. So we don't just return the number 807, we've got to build a brand new backward list 708. Okay, I know what you're probably thinking. This whole reverse order thing feels like a totally unnecessary complication, right? Like, why would anyone ever store numbers this way? But here's the thing. As we're about to find out, that seemingly bizarre rule, it's actually the key to the whole thing. And that's it, right there. This is the absolute key. That reverse order isn't a bug. It's not some mean trick the problem setter is playing on you. It's a massive hint. In fact, it's the very thing that makes a super elegant and simple solution possible. I want you to just think back for a second. Way back to grade school learning to add. If you write 342 on top of 465 on a piece of paper, where do you start? You don't start on the left with the 3 and the 4, right? No way. You start all the way on the right in the ones column. You add the 2 and the 5 first, then you move left to the tens and then the hundreds. And boom, there it is. That's the big aha moment. The list, being in reverse, is actually structured exactly the way we do math by hand. The very first digit we see in the list is the ones place. It's precisely where we need to start our calculation. So the data structure isn't a problem at all. It's actually the perfect setup for us. So this revelation leads us straight to our algorithm, and we can literally call it the grade school method. We're just going to mimic that exact process we all learned as kids. Go digit by digit and make sure we handle the carry as we go. Now, what's the most important part of that method? It's the carry, right? You know, that little 1 you'd scribble above the next column whenever a sum hit 10 or more. Well, in our algorithm, we're just going to track that with a simple variable. Easy. Okay, so here's the game plan. Step by step, we're going to walk through both lists at the exact same time. At each spot, we add the first digit plus the second digit plus whatever our carry is. The last digit of that sum, that's the next number for our answer list. And whatever is left over, it'll be a 1 or a 0, that becomes our new carry for the next step. And we just keep doing that over and over until we've run out of digits in both lists and our carry is back down to 0. All right, enough theory. Theory is great, but let's actually see this thing work. We're going to walk through our example, adding 342 and 465 using our backward lists 243 and 564. Okay, step 1, the ones column. We grab the first digits from each list, a 2 and a 5. We always start with a carry of 0. So 2 plus 5 plus 0, that's 7. Since 7 is just a single digit, our new carry is 0, and the first number in our new result list is 7. Next up, the tens column. We move to the next digits, a 4 and a 6. Our carry from the last step was 0. So 4 plus 6 plus 0, that gives us 10. Aha! Now it gets interesting. This is where the carry matters. We take the last digit of that sum, the 0, and that becomes the next part of our answer. And the first digit, the 1, that's our new carry for the next step. So our result list is now 7, 0. And finally, the hundreds column. We grab the last digits, a 3 and a 4. But wait, don't forget, we have that carry of 1 from the last step. So it's 3 plus 4 plus our carry of 1, which equals 8. Perfect. The result is 8, and our new carry is back to 0. And just like that, our final result list is 708. And there we have it. We've hit the end of both lists, and this is super important. Our carry is 0. That's our cue to stop the process.
The final result is 708, which is exactly 807 in reverse. Perfect.
Okay, so let's just take a second to recap what really makes this solution click. It really just boils down to a few key takeaways.
So, at its heart, the logic is just that grade school addition we talked about. The whole thing depends on that one little carry variable to pass info from one step to the next. And you've got to remember, the loop has to keep going as long as there are digits or if there's one last carry left over, for a case like adding 99 plus 1. And piece by piece, you build your answer, one digit at a time. And how fast is this? Well, it's super efficient. The time it takes really just depends on whichever number is longer. We only have to go through each digit once, and the amount of extra memory we use is tiny. If we don't count the answer list itself, we just need a couple of variables for the carry and to keep our place. It's a really clean and efficient solution. This quote really nails it. The solution is just so elegant. It takes what looks like a tricky data structure problem and turns it into something we all understand. Simple arithmetic. It's all about that one key insight. And that about wraps it up for this one. But I want to leave you with a question to chew on. What if the numbers weren't in reverse? What if the lists were 342 and 465? You'd still need to start adding from the end, but you can only move forward in a linked list. So, how would you solve that? Something to think about.